Hello, let us start the construction of the threaded binary tree in case of in-order traversing. Now, the structure of a threaded binary tree is given, and this is the node structure of each node in the threaded binary tree. The node has four, five different fields. One of the field is the data field which holds the actual data. Now there are two address part. This is the left address part and this is the right address part. So the left address part will hold some address and this right address part will hold some address. Now this field is a boolean field. Again, this field is also a boolean field. Now these boolean fields are used to interpret the address value, because the address can be normal address or it can be a threaded address. Now how we can interpret that? If the value of these fields, if the value of this boolean field is false, then we will assume the corresponding address part will hold the normal address. If the boolean field contains the true value, then we will consider the corresponding addresses as the threaded address. For example, consider a node structure which has 20 as its value and it has false here and true here, and it this contains some address and this contains some address. Now how we can interpret the threaded address? So first case, this is the value of the node. Now this false value indicates that the value here is the left address, or this is not threaded address. Here this true value indicate that this address at here is a threaded address. So this is the way how the boolean fields are used to indicate the addresses. Now the in order sequence of this given binary tree is here. In this sequence, the special nodes are 70 and 200. 70 is the first node under in order traversing and 200 is the last node under in order traversing. The special header node will point to this special node 70 and 200. How? This can be indicated at here. Suppose this is our header node. The left address part of the header node will point to 70 and the right address part of the header will point to 200. So the left address part of the header will point to 70 and the right part of the header will point to the last node in the in order traversing, that is 200. Now the next cases. Next we have to choose that node which contains null in its address part. So the first node is this node. So this has null in its address part, and we can see as 70 does not have any left subtree or left node, the left value is null. So we will replace this null with the threaded address. So here this is the 70. Now the 70, the left address part of 70 will point to this header node. So this will be removed and this will now point to this special header node. Similarly, the right part of this node 200 which contains null should be replaced with the threaded address. So the right address of 200 will point to the header, that is this will be removed and this will be pointing to the special header node. Okay, now consider this node. This node has one null value, so that null values must be replaced. So this is the node 30. Now this null value will be replaced by its in order successors. Now as this is 3, 120 is in order successor of 30. So 30 right link will point to the in-order successor. So this address will point to the in-order successor. So this one. Now consider this node. So this node has left address as null, so this null should be replaced by a special address. So now this is our 15 node. This left address will be replaced by the in-order predecessor. Now 70 is the in-order predecessor of 15. So the left address of 15 will point to 70. So the left address of 15 will point to 70. Now the right address part. Now 30 is the in-order successor of 15. So the right address part will be a threaded address and it will point to 30. So this will point to 30. Now consider this node. This has a null value, so that null value should be replaced by the threaded address. Now 150. So this is the 150. The left address of 150 will point to its in-order predecessor. The in-order predecessor of 150 is 120. So the left address part will contain the address of 120. So this will contain the address of 120. Done. Now consider this node. Similarly, there is a null value. That null value should be replaced with the in-order successor. So this is the node 100. The left address will contain the in-order predecessor of 100. That is one. The left address part of 100 will contain the address of 150, because 150 is the in-order predecessor of 100. So this address part will point to this node. Now consider this one. Now the right address part of 100 will point to the in-order successor of 100. So this will point to 200. So the threaded address are now replaced. Now from this figure we can say that all the violet colors represent the threaded address, and the orange can also be also be used to denote the threaded address, but the black address or the black edges are basically the non-threaded address part. So how we will use the boolean field to indicate the address, type of address. Now consider the root node. Now here, is this a threaded address? This is a threaded address? No, so it will be false. Now consider this one. This is a threaded address? No, so this will be false. Now consider this node. Now is the left address is the threaded address? Yes, so it will be true. Now is the right address is a threaded address? This is a threaded address? No, so it will be false. Now consider this node. Is the left address? This is a threaded address? No, so it will be false. Now consider this right address. Is the right address contains a threaded address? Yes, so it will be true. Now consider this node. Is the left address contains a threaded address? Yes, so it will be true. Now this one, is the right address contains a threaded address? Yes, so it will be again true. Now consider this node. Similarly, is the left address contains a threaded address? Yes, so it will be true. Is the right address contains the threaded address? No, it will be false. Now this one, is the left address is a threaded address? No, it's a structural address or the normal non-threaded address, so it will be false. Is the right address is the threaded address? Yes, so it will be true. Now consider this node. Is the left address is a threaded address? Yes, so it will be true, and similarly it will be also true. So this is the way how we can construct the threaded binary tree from a given binary tree. So in this example we have used these two different color to indicate the threaded address and the single black color to use the non-threaded address. Thank you.